students, welcome to the fourth video. In continuation to the last video, we'll proceed further with the algebra of matrices. In last video, we have seen about addition and its property, difference of matrices and its property. Now in this video, we'll start with the third operation on matrix, that is the multiplication of a matrix and a scalar. Scalar means we have to consider a constant, a real number. So how can we multiply a scalar and a matrix? So first I'll give you one example. Like this is a matrix of order 3 by 2. And I want to obtain 4a. So 4 is a real number, a is a matrix. So 4a is a matrix which is obtained by multiplying every element of a with the scalar. So here every element of this matrix can be added with 4, multiplied with 4, sorry. So 3 into 4 will be 12, 5 into 4, 20, minus 1 into 4, minus 4. 2 into 4, 8, 6 into 4, 24, 2 into 4, 8. Again it will be of the same order. So a and 4a will be of same order. So now if we generalize this and go to the definition, so if a is equal to aij is any matrix of order m by n and k is a scalar, means it's a real number, then ka is a matrix kaij, that is a matrix obtained by every element aij with scalar k will be of the same order as a. So this is the example. So now we go to the properties of scalar multiplication. So as you have seen that a is a matrix, k is a scalar, then ka is also a matrix. So ka is a matrix of same order as a. Second, if I multiply a null matrix to a, 0 into a, that is every element of a is multiplied with 0. So what do we get? Yes, of course we'll get a matrix whose all elements are 0. That we get a 0 matrix. So 0 matrix into a is a 0 matrix like this. Now what if I multiply the identity matrix I with a? Student, I into a will be a as a into I, but that we'll see later on. If I multiply the real number 1 with a, then it will be a only. As every element is multiplied with 1, 1 into aij will be aij. Now the fourth property, student, that if k is a scalar and a and b are matrices of the same order. I repeat, k is a scalar and a and b are matrices of the same order, so that a plus b will be possible. Then it will be same as ka plus kb. What is the meaning of this property? That first I add the two matrices and then multiply the resultant with k, or I first multiply k to individually to a and b and then I add them, the answer will be equal matrices. The same we can do for minus k into a minus b is equal to ka minus kb. Same way, if k and l are scalars and a is a matrix, then it is ka plus la. Just for example, suppose I want to do 2a plus 3a and then ultimately I'll get 5a, or first I do 2 plus 3 5 and multiply 5 to a, the resultant will be the same. And same way we can go with the sixth property, that is if k and l are scalars and a is a matrix, then kl into a is equal to k into LA is equal to L into K. For example, I first multiply A with 2 and obtain 2A. Then I multiply 2A with 3, so it will be 6A. Or I directly obtain 6A. The answer will be the same. So these are the 6 properties of scalar multiplication. So any metric multiplied with a scalar K is giving Ka, which will be the metric of the same order as A. So it's quite an easy operation. So student, till now we have seen 3 operations on the matrices: addition, subtraction and multiplication with a scalar. Now one more operation is left, that is the multiplication between the 2 matrices. But that we'll see in the next lecture. Before we go to that, based on these 3 operations, let us solve some of the questions which can come for 2 mark or 4 mark in the exam. Like A is equal to diagonal matrix 1 minus 2 3. B is equal to diagonal matrix 3 4 minus 6. C is equal to diagonal matrix 0 1 2. Then obtain the resultant of A minus 2B plus 3C. So student, as this is diagonal matrix of order 3 by 3, it can be written in the expanded form as 1 0 0, 0 minus 2 0 and 0 0 3. This is minus 2. B can be written as 3 0 0, 0 4 0 and 0 0 minus 6 plus 3. C can be written as 0 0 0, 0 1 0 and 0 0 2. So I write A as it is. Then I multiply minus to each of these elements. So it is minus 6 0 0, 0 minus 8 0, 0 0 minus minus plus 12. Be careful student, this will be plus 12. Same way I multiply scalar 3 to each of this element of C. So 0 0 0, 0 3 0, 0 0 6. Now we want to add them. So adding means what? Adding the corresponding elements, and we have seen that it is commutative as well as associative. So we can directly add them. So it is 1 plus minus 6 plus 0, 0 plus 0 plus 0 and 0 plus 0 plus 0. Now we move to the second column element. 0 plus 0 plus 0, minus 2 plus minus 8 plus 3, 0 plus 0 plus 0. Now we move to the third column. 0 plus 0 plus 0, 0 plus 0 plus 0, 3 plus 12 plus 6. So what do we get the resultant as? 1 plus minus 6 is minus 5, 0 plus 0 plus 0, this is 0, minus 2 minus 8 is minus 10 plus 3 is minus 7 and this is 0, this is 0, 0 and 21. As you can see here also all non-diagonal elements are 0. So in short, we can write it as it is a diagonal matrix minus 5, minus 7, 21. So this is how you can use the addition, subtraction and scalar multiplication. Now, one more question. If we have then find the matrix A. So student, what is the order of this matrix? 2 rows, 3 columns. This is also 2 rows, 3 columns, and the addition sign is between them. So A will be a matrix of order 2 by 3. Now we shift this to the opposite side, or we can say we are adding the negative matrix of this. How quite similar to how you are doing in real numbers. So 3 minus 1, 2, minus 1 minus 0, minus 1, 5 minus 2, 3, 0 minus 4 is minus 4, 6 minus 3 is 9, 3 minus 1 is 2. So this is a matrix which you require. Now we proceed further, which to solve the linear equations involving matrices. This type of questions are given to you in your NCERT textbook also. If A and B are matrices of the same order such that 2A plus 3B is equal to and A minus 2B is equal to then find the matrices A and B. Now you can see student here 2A plus 3B is giving you a matrix of order 2 by 3. A minus 2B is also giving a matrix of order 2 by 3. So that obvious that A and B are also of the same order as same 2 by 3. We want to find AB. Student, if you observe this, right, it look quite similar to the linear equations what you have studied last year. In 10th standard you have studied linear equation last year, and there you have studied elimination substitution method for linear equation. Almost similar to that we are using it. The only difference is there x, y or AB are the real numbers, here x, y or AB are the matrices. So this is 2A and this is A. So obviously I'll call this as equation 1, this as equation 2. I want to eliminate A. So what I'll do is equation 1 minus 2 times equation 2. So it will be 2A plus 3B minus 2 times A minus 2B is equal to the first is as it is minus 2 times this. So what I'll get is this 2 is multiplied with A as well as B, and as it is minus sign, it is minus 2A plus 4B is equal to now I multiply minus 2 to each of this element. So minus 6, 2, 0, minus 12, minus 2 and minus 4. Here you can see plus 2A and minus 2A is getting 0 matrix. 0 matrix plus 3B plus 4B will be 7b. 1 minus 6 is minus 5. 2 plus 2 is 4. Minus 2 plus 0, minus 2. 0 minus 12. Minus 12. 3 minus 2 is 1. Minus 1 minus 4 is minus 5. So our matrix B will be 1 by 7 of it. This is 7b. So B is 1 by 7 of so each element is multiplied with 1 by 7. So it is minus 5 by 7, 4 by 7, minus 2 by 7, minus 12 by 7, 1 by 7 and minus 5 by 7 of order 2 by 3. So this is what matrix B is. Now if we want to find matrix A, then we have to remove B, or we can substitute in either of the two equations. So one of the option is you multiply this equation with 2, this with 3 and add. So B will be eliminated. I will do the substitution method. So substitute B. I'll call this result number 3. So from equation 2 and 3, I'll have A minus 2B so A can be written as plus 2B. On the shifting on opposite side, we'll change the sign. Now I substitute the value of B. It will be like this. Now as we have to multiply the scalar 2 to each of this element. So it is minus 10 by 7, 8 by 7, minus 4 by 7, minus 24 by 7, 2 by 7, minus 10 by 7. Now the plus sign between the two, so we have to add the corresponding elements. So it will be 3 minus 10 by 7, minus 1 plus 8 by 7, second column element, 0 minus 4 by 7, 6 minus 24 by 7, third column element, 1 plus 2 by 7, 2 minus 10 by 7. On taking LCM and simplifying, 7 3s are 21 minus 10. So it will be 11 by 7, minus 7 plus 8, 1 by 7, 0 minus 4 by 7, minus 4 by 7, 7 6 are 42 minus 24. By 7, 7 plus 2, 9 by 7, 14 minus 10, 4 by 7. So this is your resultant A. A is 11 by 7, 1 by 7, minus 4 by 7, 18 by 7, 9 by 7 and 4 by 7 of order 2 by 3. So this is how you can solve the matrix equation. So this type of equation will come for 4 mark. And easy comparatively. So now some of the questions which you can try on your own. If 2x plus 3y is equal to and 3x plus 2y is equal to Then find the matrices x and pi. This is the first question. The second question is find the matrix x such that 2a minus b plus x is 0, where A is a matrix and B is a matrix given as and you can try exercise number 3.2 from NCERT, as there are some of the questions based on multiplication also, but you can try this till question number 12 except the third. So that's all for today. Thank you so much. Keep watching.